link has two sides, one's A, one's B. If you have two A's, they will not talk to each other, two B's won't talk to each other. It has to be an A and a B side.
And that's the diplexer difference?
Yes. So one is a high band, one is a low side. The A is going to be your low side transmitter, and the B is going to be your high side transmitter. When you do a model command, what are you going to see? You're going to see the ODU detector first of all, and then you're going to see the actual frequency ranges you can input for that ODU. Questions on anything from yesterday? Nope? You guys gonna ace the test?
Perfect.
Of course.
Easy one.
Okay, so as we've been talking about here, the training, the one thing I need you to learn, even if you don't take anything from this training,
Put it on the bench.
put it on the bench. You guys ready to go? You guys know you passed the test. So yes, when you get your gear, it's gonna be pre-configured by Triangle, based on your PCN if it's a licensed gear, a licensed link. First, you want to do, you want to take it out of the box, put it on the bench, power up. Remember, Triangle radios can be powered up via PoE and direct power, the all outdoors. Try both. Get a negative 48 DC, plug it in, get the PoE, swap them between each other, make sure it powers up the radio. For the indoor units, you only got the Regnic 48. For bench testing the actual radio, when you get it from Triangle, take it out of the box. If you don't have attenuators, you have to do a poor men's bench test. The way to do that is either you put them on top of each other, put a rim of paper, that's the best attenuator you can have. If not, put them 3 or 5 feet apart, also works decent enough. You will have reflection and bounces all over the place, but for test modulation, 1024, 512 it'll work. All you want to do is do a ping across. You want to make sure you can talk across the link, send traffic. When you're on the bench, lower the actual power of the transmitters. You don't want to have all full power. It's not going to hurt the radio, but it's going to overdrive the transmitter. So you're probably going to get a really bad RSSI. If you lower the power, you're going to get a little better signal. Verify from the web interface or the CLI, the radio link lock. So one thing I'm going to show you guys as well, physically we can tell if the radio is locked or not. In the all outdoor models, it's gonna be a little hard to see, but where that direct connector is, the negative 48 power connector, when you turn it on, right on the bottom of that is gonna be a bright green LED. That LED has two purposes. It's a link-like indicator. When you first boot up the radio, it's gonna be solid. That means booting up. After the boot up process, it's gonna flash. When it's flashing, that means it is transmitting and it's ready to receive as well. When it's solid again, that means you have a link lock. So physically, you can actually know if the radio is locked or not. What is this good for? Alignment purposes. If you have you're aligning the radio, you're moving it back and forward, you can see when the actual radio locks. That at least gives you an idea that you're in the ballpark. You're close to the actual alignment range. Okay? That's on the all outdoor products. In the split systems, you have two LEDs to indicate. One is the ODU indicator, the other one is the link indicator. The ODU indicator tells you if the ODU has power or not. If it's green, do not take the end connector off. If it's amber, you can disconnect it safely. When it says link, if it's green, it's a lock. If it's amber, it's no lock. So we have physical aspects that can help us see if our radio is linked or not. Then config, save, and reboot verify all settings. Config, save, and reboot. It's on the bench, you're playing with it. Remember, if you change anything and you send it out to the tower sites and you forgot to actually config, save, when they get there, they're not going to work. You have to make sure after the reboot they come back and make a link lock. I know that on our previous products, and I keep going back because a lot of you guys have Apex Pluses, Giga Pluses. Before we had a setting called default off mode, right? If that was set to off, when it rebooted, it would not transmit. In the new radios, it's already enabled by default. There's no way it will not come up transmitting, unless it was turn off transmitting, out mode off. So that's a good thing. So again, most important thing, when you get your gear, put it on the bench, please. I don't want to get the call. Jose, how are you? Good. How are you doing? Perfect. What's the problem? It doesn't power on, it doesn't link. Did you test it before you put it up? Yeah, I gotta call you back. Okay? So please, come on guys. Something to consider here, just on outdoor models and split systems. For the all outdoor models, in all our radios, the Ethernet cable must be shielded cable, okay, for the ground and the grain. I would not recommend going above 250 feet. Keep it 250 feet and below. The radios are not standard PoE 803.11 AF, and that's a good point I want to make. If you grab one of our radios and you try to connect it to a PoE switch from Cisco, Netgear, Brocade, even a PoE injector from any brand, it's not going to power up. Okay, so it's not AF. You have to use it. You have to use a particular PoE injector. For the split systems, use -48 triangle power supplies. It is recommended. I know in telecom there's big power supplies. I think who makes Smith Power? I think makes one. Who else makes one?
APC. There's a lot of them.
APC. Yeah. Now it's -48. It doesn't mean you can cross the wires and it's gonna be -48. It has to be actually a -48 power supply. Okay. Even if it's DC, there's rules to this. So which is a -48 power supply. Right?
Okay.
Connect the IF cable to the IDU before power up. So right now, I'm safe to go ahead and connect and disconnect and pinch my cable on the top of the grounding bolt every time I want to. Right? Because there's nothing going to power the ODU. But if I power up the IDU and then plug it in, I run the risk of creating a short circuit on the IF cable. If the center connector touches the outer connector, the IF cable is going to make it short, and I'm going to blow my end connector fuse here. If I do that, the only way I have to check it is I turn ODU power on, I grab my multimeter, put the center connector in the middle, and then on the outer part, the grounding, it has to read -48. If you don't have a -48 voltage on that end connector, it has to come back to the factory. Okay? Do not disconnect or connect the IF cable while the device is in operation. Again, golden rule, IF cables are only supposed to be connected and disconnected when there's no power going to the ODU. Okay, so with that said, I'm going to move into today's agenda. I'll give you a chance, you guys. Any questions?
Before I forget,
Yes.
that radio's shifting about 130 times a day.
Yeah, that's not really good. Clear skies?
I mean, every day is perfect. I'm sure the last couple days we've had some smoke, fires, and whatnot. But
All right, we'll check the ATPC power and see if that has to do with it. Because remember I told you that if you set the RSSI, target RSSI, if it's not the correct one, ATPC may be powering up and down the radio. So let's try that later. Okay?
understood. Cool.
Please.
Just to make sure, when we're testing with the voltmeter,
Yes.
that's the one where you don't touch the pins on the voltmeter or it damages the IDU?
It damages the end connector in the IDU.
Oh, okay.
Yeah, not the IDU itself. So only here. The IDU is still going to power on. You can get access to it. You can do whatever you want management-wise. Change IP, SNMP traps, passwords. Everything's going to work. The only thing that's not going to work is your ODE. Now, see that fuse here that is right here? This is to protect the actual IDU itself. If there's a -48 discharge here, or for some reason it gets a really heavy load, it's going to protect, it's going to break the fuse. Okay? There's a diode inside as well, protection diode. So if you invert the actual DC, -48, put the power on the ground and ground the power, you will not burn it up. It will protect it.
Is that fuse field replaceable?
Yes, it's a standard.
GMT, isn't it?
No, it's a bus fuse. It's a little
It's about,
glass.
yeah, it's a little.
Just like in your PoE.
Yeah,
Yeah.
exactly. It's a little bus fuse.
Round.
You can buy them in any hardware store. Also on the PoEs, the new ones and the old this guy's here as well. Inside there's an extra fuse for each purpose. Alright, so today's agenda, typically what John tells you and what I tell you is a little different all the time. Link commission and validation, we're going to talk about. We already know how to manage a radio, test a radio, traffic-wise, we know how to log into them, web interface, CLI. You guys are expert at the CLI. I know you look at me with Cisco eyes, so like, you know, CCNP, CCIE, all that. Now we're going to talk about, once we get our link up and running, what do we need to know to commission the link, okay? After that, I'm going to jump into network monitoring with Triangle NMS and PRTG. Maybe I'm going to leave Triangle NMS to John. He likes to do that. You're the guy, John. And I'd probably take the PRTG. Let's see how it goes. So SNMP for monitoring. This is one of the most important topics as well. The reason why is because when you get a link up and running, it could be passing traffic all day long, day and night, no problems, but you need to monitor your link. You need to see what's happening on the RF level and traffic wise as well. First of all, RSSI, MSC, and VERs. If the RSSI goes up and down, something's happening. Power, interference, your MSC goes down, what's happening, okay? If there's bad weather, you can see ACM shifting up and down. Traffic-wise, you have to monitor the ports. How much traffic am I passing through my Ethernet? Now, besides that, you can monitor packet statistics, temperatures. There's a number of parameters. I recommend 10 always. You don't want to stress the radio too much, grabbing parameters all the time. A recommended pull time is 60 seconds per parameter. IBM configuration and network setup. I know that IBM is pretty basic and you guys already know it, and OBM, so you know the difference and you can actually enable it. So the thing here for IBM is we're going to see how to enable IBM with a tag set on tagging. On the network side, what do we need in our switch? What do we need to declare? If it's a Cisco, allowed trunk, VLAN, 802.1q, things like that. Firmware upgrade. There's two ways to do a firmware upgrade on the radio. Yeah, TFTP or FTP. It's the CLI. There's no way around it. Maybe down the line, I said maybe, we'll think about web interface. Right now, everything is synchronized. So the main difference is TFTP is going directly from your local computer to the radio. FTP, you can either pull it from our FTP server in Triangle or from your local server as well in your network. It's up to you. FTP has a checksum at the end, so it will be a little more, well, it's more secure, and if the file is complete, it will tell you. If it's not, it will tell you, look, I didn't get a complete file. TFTP, it's a toss, right? It's a connectionless protocol, so really you don't have any confirmation that the file actually got to the destination. You will get, okay, I got the file, but that's it. In what state, what size, I don't know. I just know I received the file. However, with that said, TFTP is really practical. Because sometimes you're in the tower, you just connect to the radio, or you have access to the radio via your network. If you can ping it, you can TFTP. Okay?
I mean, you may go into more detail about this, but can you answer a question about that?
Yeah.
So does the Trango software do a CRC check or an MD5 or something, just to know that before it goes and puts that software in there that, yeah, that's legit, or does it just go, you know, you said it's good, I'm going to boot and I'm going to die?
No, so so there's a check. Well, there's MD5. So what happens is you can push any file to the radio, and by that I mean a text file, bin file, anything you want. When you execute the actual firmware, when you do the boot image command, there's the most important check. If it is not designed for that radio, it will just start and then it will kill the process, so you cannot break the radio basically.
So it'll tell you that before you're rebooting into that thing.
Yes.
So basically, it checks that software is legit for that model and it's a good copy before it attempts to boot from it.
Correct.
So it's not like it's going to check when it's booting up and go, you're screwed, have a good time, come to the mountain.
Yes.
Yeah.
But with that said, remember we have SF24E and non-encrypted. So let's just check on that model. That's the only thing I want to touch bases on that. On the licensed gear, it's a little more difficult to break the radio via firmware. On the unlicensed, I have people that have, by mistake, loaded the SF24E to the unencrypted. It will still boot up, it will not lock, and it will create weird behavior. But the same, the checksum is the same for that specific model. This is the same platform. For the other ones, you have specific Orion or Lynx platforms. It's a little different. Okay. So we're going to go into detail of that. I mean, we're going to actually do a firmware upgrade, and you guys will do it as well. My favorite subject, lunch. Okay? I ace that class all the time. Then we have a factory visit. So you guys are going to go see the RSNT assembly. You're going to get to see how we actually build the IDU, build the OMU. We do not build ODUs, okay? None of the microwave manufacturers do. I think nobody actually does it. ODUs are third-party manufacturer. We only manufacture the OMUs and the IDUs, okay? With that said, sparing purposes depends on availability of the ODU. We do fabricate everything here. We assemble it, so they're made in the US. VISIO stencils. I know you guys have big networks, and I mean real infrastructure, towers going probably through states, a lot of miles. One way to have track of them is either your SNMP monitoring. However, you also want really nice documentation of it. So having VISIO files from our IDUs and ODUs is really a nice way to have a nice document with IPs, with labels, and everything really nice and clear. This helps either your integrator, your install guys, fuel guys, to just have a good actual documentation. It's perfect. On the VISIO stencils, we already have pre-made for you 18-inch racks, just drag and drop. Get a CPA, get a APC rack just from VISIO. You can drag and drop. Power supplies, everything. So it's really nice. And it's free. Then, link configuration practice. So this practice is here when we're going to go through all what we've been talking about from yesterday and today. We're going to look at the radios. They may have problems. Right? Somebody may go in there and they didn't come to the training and they don't know what they're doing basically. So they may, change the things or two on the radio and you're going to have to fix it. And a lot of times, I'm going to give you a little heads up here. A lot of times it's not because you don't know what you're doing. I had people here, 35 people in the class, and they're right next to each other, and the problem is they don't communicate. That's the number one thing. You can be doing everything correct, checking, frequencies, checking speed, checking XPIC stats, PLA stats, but the problem is you don't talk to each other right next to each other. Imagine, tower sites away. So you have to communicate with the other team to really get this running. Just keep that in mind. And then we will see if you pass the test. All right?
What time do you guys usually wrap?
Typically it depends on the size of the class. A small class, we can go a little more. I figure around 4 o'clock, maybe. The link configuration practice, it's a small group, so I think it's gonna go really fast, unless somebody really messes up the radios. But if that's the last practice for us, we finish with that. So, okay. And then troubleshooting. Troubleshooting, literally, I just glance at it because all the troubleshooting you're gonna do first here, hands-on, is what you're gonna see on the field. So now we just go through the actual slides and say, well, remember when this happened to you, this is what you have to do. So you already did the process, now you're gonna realize why. And lastly, Q&A. So 4 o'clock, 4-ish, depends on you when we finish, but typically it's before 4. Yeah.
So the exam is just somewhere wedged in there?
Yes.
Okay.
Okay, so.
We all want to be successful.
Of course. Okay guys, again, the support portal from Triangle, support.trianglesys.com. You can come here and you will find everything for each radio, software, firmware upgrades, how-to guides, SNMP MIBs, anything you can find. Question on the radio is going to be here in the support portal. And you can have a ticket from here.
You have to, is that something you have to register for?
Yes, yeah, just put in your email address and then you pretty much get a user. So you can have a history of tickets.
Can you actually go through and review your tickets in there? Okay.
Yes, the history, yes, you can.
That link up there, check your existing request.
Oh, all right.
So your account is going to have how many times you interact with us, and you can go back and do follow-ups as well. For example, let's say you fix something and you think it's not really fixed, you can go and say, hey guys, let's take a look at this again. things like that. Alright, so just to recap again, when we're troubleshooting a link configuration, what do we need to check first? Frequencies, transmit and receive, right? My TX has to be the RX of the far side. Frequency duplex has to be the same. TX power. What happens if I have different TX powers on each side? One.
You're not gonna have the same signal.
Correct.
It could lock.
It will lock. But the RSSI will be probably 10 dB off, depending on the difference between dBs.
Oh, okay.
So the reason I say this is because, again, antenna alignment problems is symmetrical RSSI loss. If you have negative, for example, 44, and one antenna moves ever so slightly, both sides are going to move up. So you want negative 55, negative 60, but it's symmetrical. If you have the situation where some antennas has a negative 60, negative 32, oh boy, either power or something else is going on. Interference, polarization, cross pole, things like that. But a sure sign of alignment is symmetrical RSI disruption. If not, typically the power.
How symmetrical is it, like within a dB of each other? Or
When
maybe
alignment?
exact?
It's almost exact. I mean,
Almost,
really, it's really,
yeah.
really
Okay.
precise.
Okay.
And when you do the cross pole, you're gonna see 20 dBs exact. It's 20 dB phase. So you will see the actual 20, 40, 60, 50, 70, you will see it. And you gotta go up the tower, unclick the ODU, turn it, and it's gonna be fixed.
And this is, I probably will never do this, but I mean, there's no reason that an Orion couldn't talk to Lynx. Could. I mean, is there anything that would keep that from happening? Like if you had to do this for some dumb reason, you had to be split system on one end and all outdoor the other. Will they talk to each other? Will they lock?
They will lock to each other. Recommendation from Triangle, it's keep it the same,
Yeah.
of course. Now, when you said Orion Lynx, no. We have to have a Lynx, Orion. The reason why, because the features-wise, one of the other different. But
yeah.
as long as you have, for example, one outdoor Orion and one split Orion, that's possible. Okay, but cross-platforms, it won't really work.
Because of incompatible features between them.
Correct. XPIC and PLA, a lot more binaries.
Yeah.
On the past products, for example, people wanted to do Apex Plus with Apexes, things like that. I would recommend having the same platform just because of ease of use. Sometimes you get a little bug in the software, so just keep it the same.
Yeah.
Then we're going back, TX power, transmitter on or off, channel bandwidth. Again, channel bandwidth is the key here. It's really easy to overlook this, but channel bandwidth, if it's 160, 120, that's enough to have a good RSSI, screaming RSSI actually, but it will not lock. Min and max modulation, have to be the same. ODU power, on or off. Okay, lane commission and validation.